Hey, hello everyone, and this is Raju Mojumdar, and thank you for watching this video. Let's solve another one lead code question. So let's first explore the problem statement. So what does it say? We have provided a array, and in this array, all the numbers appears twice except one, and we have to find out that number. So if you look at the first example, then you will see 2 is appear twice and 1 is appears once. So that's why our answer is 1. And if you look at the second example, then you can see all the numbers appears twice except 4. That's why our answer is 4. And in third example, we have provided only one numbers, so that's why our answer is 1. So this is the problem statement. Now I know after getting this problem statement from your interviewer, you are thinking, okay, how can I solve this problem, right? And what is the most optimal way to solve this problem, right? But I would recommend you, after getting the problem statement from your interviewer, you first need to discuss like what are the constraints you should consider to solve this problem, right? Because in real interview, if you never ask like what are the constraints of this problem statement, then your interviewer are never going to discuss with you. So this is our responsibility as a candidate to find out all the constraints to solve this problem, right? So, so what do you think? What are the constraints we should ask or we should discuss with our interviewer? Okay. So the first thing is, I think you should discuss. Okay, in this array, are those numbers are in sorted order? The first question is sorted. You can ask your interviewer, because there is three example, but in real interview your interviewer maybe give you, suppose, like this an example. Then if you assume, okay, the numbers are in sorted order, then it would be a very bad impression. It will create a very bad impression about you, right? So you definitely ask like, are those number in sorted order? Then your interviewer says, okay, no. Okay. The second constraint, okay, what is the maximum length of the of this array, like, because this is also very important, because if the input size is small and if the input size is huge, then you actually use different type of algorithm, right? Different type of data structures, right? So that's why you definitely need to know like what is the maximum length of this array, right? So suppose your interview says it is less than 10 to the 5. Then the next things you should ask, okay, what is the max size, what is the max size of each element, right? You need to ask this things as well, because if the array element size is huge, then you need to choose different type of calculation or process, right? So that's why actually you definitely need to ask, okay, what is the max size of each element? Or it could be like, are there only integer number, or are there any decimal number, or are there any negative numbers? You definitely discuss with your interviewer, because if the integer is also, there is also a possibility you have to discuss, like, if there is any do I need to handle like integer overflow? So because this is very important because when you actually trying to solve this problem. So suppose user interviews, okay, your interviewer says, okay, all the array elements are less than 10 to the power 5. Okay, fine. Now the fourth things you can ask, okay, what should I return if there is no answer, right? This is also very important, you need to know, because if you at the end you are actually going to implement a function, right? And your function should be unit testable. So unit testable means it should handle all the corner cases, right? So that's why you definitely ask, okay, if there is no answer, then why, what should I return, right? So suppose your interview says you can return -1 if there is no answer, okay? Or he can say there is definitely answer, you don't need to handle it, right? But you definitely need to discuss with your interviewer, okay? Okay, the fifth things you can ask, okay, if the input array is empty, then what should I return? Because this is also a possibility, uh, because at the end you would become a software engineer and you will write code for real problem. So in real problem statement input, because you will write a function which is actually expecting a input array, right? But it is not uh, always correct to expect, like our input array always give a expected parameter, right? Expected input element. So that's why we have to handle it as well. Okay, if the array is empty, then what should I return? Then your interview says, okay, you can return -1, right? Okay, now suppose these are the constraints you need to consider. To these are the constraints, okay, you need to consider to solve this problem. Okay, now you have the problem statement and you have the all the constraints. Now you can think about, like, how can you solve this problem. So here is one more thing. Sometimes you have some situation where you don't have any idea, like what is the most optimal way to solve this problem. So in that case, I would recommend you to start with brute force solution, so that you would have a baseline. Then you can actually incrementally optimize your solution, right? Okay, so we'll also start with brute force solution for this problem statement. Though you can if you know the most optimal answer, then you can directly go for it. But if you don't know, then I would recommend you start with brute force solution, right? Okay. So what do you think? What is the brute force solution for this problem statement? Okay. So let me write a input array. Suppose if the input array like that, suppose this is the input array, okay. Now what I need to know actually, I actually uh, will take every element. I will take every element. I need to know, okay, suppose I will take this element and compare with all other elements, right? With all other elements, to need to know, because is this number or exist in other places of this array, right? I should need to know, to but to identify it, I need to compare with all other numbers, right? So suppose I start with this number and then I say, oh, I see it is exist in this place. Okay, then move it here. Then I can see it is also exist in this area. Then move it. Then start with it again. I can see it is also present, right? Then I start with again. Then I can see it is also present. Then I start with again. Then I can see it is not present in whole array. Then our answer is this one, right? This is our answer. So you see what you see, we have to actually compare with all other numbers to find out is this number duplicate or not, right? So in that case, suppose if in this array if there is like n numbers, n number of elements, then I have to compare with n minus 1 numbers of element to find out is this number present or not. In that case, it is in big O, it is actually quadratic, right? So our brute force solution actually in quadratic time complexity, because we have to actually how do you solve it? Suppose you need to use two for loop, right? One for loop actually go through whole array one by one, and another one for loop to compare this number, right? So in that case, actually you have to actually run two for loop. One is inner loop. That's actually our brute force solution actually quadratic, right? And this is actually time and space actually constant, because we are not using any auxiliary space, right? So now you have a baseline, right? Now you have a baseline. This is our baseline, right? So this is right. This is our baseline. The solution we know for this problem statement is time complexity is quadratic, space complexity constant. Now, now we have to find out a better solution, right? We have to find out a better solution. Okay, how can we do that? Okay, let's start with another one example. Find out, if you need to find out a solution in n log n, then you definitely need to think about, okay, uh, can can I apply any sorting algorithm so that I can achieve this time complexity, right? You can think about it. Okay, let's try. If we sort this array, then how can it really help us in comparison, right? So suppose this is the array, and if we actually sort it, then it will become like this, right? Now you see, there is an interesting things happen. In our brute force solution, what we had to do, we had to actually compare uh, with all the elements in this area to find out if this number exists or not. But if we sort it, then actually we don't need to compare with all other numbers. Why? Because you see, the duplicate number is adjacent with each other, right? With each other. You see, they are adjacent. So what we need to do, what we need to do, we need to only compare with our adjacent number, is it duplicate or not. Then we don't need to actually compare like whole array, right? So it will actually help us to like to help us to find out a better solution. Why? How? Because now we don't need to actually run two for loop. We can do it in one for loop, because after sorting, what we need to do, we just start from here, then compare with my adjacent number, is it duplicate or not. If it is duplicate, then we can move here. Then we can compare it. If it is duplicate, then we move here. Then if it is duplicate, then we move here. Okay, there is no unknown, then that's our answer, right? So in one loop, we can actually, in one for loop, we can actually find out which is our correct answer, right? So that's why actually it actually like reduce our time complexity. So in this solution, what is the time complexity for this solution? Because we need to apply sorting algorithm. So the best we can get from any sorting algorithm, which is suppose big O n log n, right? And then we need to run a for loop to find out to compare and find out our answer. So this is also linear, right? We have to actually go through whole array. So this is our time complexity, but in big O the actual time complexity is big O of n log n, right? This is our upper bound, right? So now we have two solutions. One is brute force solution, another one is sorting based solution. And in sorting based solution, the time complexity is n log n, and space complexity is still same. Space is still same. Still actually is constant. We are not using any constant. We are not using any auxiliary x space, right? Okay. Now now think about another thing. Now, so if you look at again in BIGO chart, so what we have quadratic, then we have another one, this is n log n. Now we need to down in linear solution. So we have to find out a linear solution, right? Now, to find out a linear solution, here you can see we can't use any sorting algorithm, because if we use sorting algorithm, then it will increase our time complexity, right? So how can I solve this in linear time? I don't know, do you notice it or not? Here one thing we needed to find out a linear solution. What we are doing here, I just write down the number again. Okay, we need to know, we need someone, or we need some guy who can help us, like in Boolean way. Suppose we ask him, hey, is this number appear in other places or not? Hey, is this number appear in other places or not? We need someone, or we need some function, we need something which actually help us in constant time, who actually give us the answer, okay, is this number duplicate or not? If we have any function or anyone who can actually give us the answer in constant time, then actually we can solve it in linear time, right? Otherwise we can't. So how what do you think? How can actually, who is actually going to give us answer in constant time? So in this type of situation, like if you are thinking to optimize your solution, I would recommend you to think about like different type of data structures or different type of algorithm. So because we have different type of data structure, and and different data structure has actually different type of time complexity, like create, update, delete, right? Include operation, right? They have actually different type of time complexity. So in that case, which data structure we can use, or any other algorithm we can use? So you just think like that way, right? So what do you think? What type of data structure we can use? Like what we need to know? We need to know someone who actually give us answer in constant time. Is this number exist or not, right? Is this number exist or not? Okay. So there is one data structure which is very popular and very interesting, which is actually hash map. So hash map. So how can actually it help us, and how can actually hash map help us in this problem statement? Okay, the main advantage of hash map is in constant time we can find, it's actually key value data structure. It's a key and value. So in constant time we can identify is the key exist or not. The main advantage of hash map. So then how actually hash map help us, and then what is the key? Okay, if we send this array to our hash map, then what he will do, he will actually pre-process it. what does it mean? What does it mean? That means suppose if we send this array, then it will create a hash map like that. Suppose 1 2 times 2 2 times 3 2 times 4 1 times. This is the hash map actually prepare this data to give us answer in constant time, is this number duplicate or not. So this is our key and this is the value. So what we need to do, we just suppose we run a for loop for this array and then take this number and ask this guy, hey, is this number appeared twice or not? Then he will say yes, because in constant time he will say this twice. Then I will ask him again, hey, 2 is appear twice in this array. Then he will say yes, right? Then I will ask again for 1, I will ask again for 3, I will ask again for 2, I will ask again for 3, then I will ask again for 4. And if we ask for 4, then he will answer no, because it is not appear in twice. So in that way, it will actually help us to solve it in linear time. But there is one disadvantage, because he is doing actually good job, but he is taking some another thing for a trade-off. He has to store this data, right? He has to store this information in his memory to give us the answer, right? He has to keep this information in his brain so that he can give us answer in constant time. For that, actually, our time complexity is linear, but our space complexity is also linear. Though he is not actually taking like linear space, because most of the time we'll say n by 2 plus 1 space, but in Bigo we can keep it in linear. So this is the disadvantage, like hash map solution. It actually increases space complexity. So, but it's actually like whatever you are doing, whatever there is no, suppose in problem solution or in very like related in system design also, there is no like, most of the time we have to actually trade up, we have to actually choose which one we need it based on our environment, based on our situation. We have to actually pick the solution, right? So that's actually you have to know all the possible solution, then we can take which one actually appropriate for us, right? So this is our hash map solution. Came up with this solution in real interview, because if you don't have the experience and if you don't have the knowledge about bitwise operation, then it's very difficult to come up with a solution like this, right? So the next solution we are trying to discuss, which is actually bitwise operation based solution. So here actually we need to know something, we need to know some theory as well. So suppose you already have a better like XOR operation, XOR. You definitely have knowledge about it, because in DLD or number system you definitely have studied it, right? So I just make it simple. So what XOR did, actually, if there is a 2-bit, suppose, then if 0 and 0 bit XOR, then it's actually 0. If 0 1 XOR, then it's 1, and 1 XOR 0 is actually 1, and 1 XOR 1 actually 0. So same bit is actually 0, and alternate bit is actually 1. This is the actual XOR operation. And you need to know two more formula uh, for XOR for this to understand this solution. One is, if we XOR with any other numbers, suppose if we with 0, then the output is that number. And if two same number, if we XOR, then it will be 0. So this is also a formula. You definitely need to know about it to understand the solution. So I hope you now understand. Okay, so if 0 XOR, if we XOR with any uh, mm, like any number with 0, then we the answer is 5, and if the two same number we did XOR, then actually it is 0. So in our example, you see there is actually except one number, all other numbers in pair, right? So that's actually, suppose 1 1 2 2 3 3, they will become actually 0, right? They will become 0, they will become 0, they will become 0, and it remains only 4. So if we XOR with 4 with 0, then we know that it will answer 4. So that's why actually, if we run a XOR operation in all the numbers in this array, then we can actually find out our single number, which is not twice, which is not appearing twice. So this is actually a bitwise operation, and I hope this is very implementation is also simple. So let's see how can we already discussed like 4 different solution, but we are going to implement last 2 solution, which one is actually our hash map base, and the next one is actually bitwise XOR bitwise based solution. So let's go for it, because we just need to go through run a loop in this array for all elements, and we are not using any space actually, but in our hash map solution we are using auxiliary space, linear space. So in that case, that's actually constant. So this is our most optimal solution for this problem statement. We can actually go down from this linear solution, because suppose if you look at again our Vigo chart quadratic, then we down actually n log n, then we down actually linear, then we have actually log n, but we can go we can solve it in log n time complexity, because we have to actually at least compare all the numbers to know is this number exist or not, right? So at least we have to run a loop. So that's actually we don't have any. So this is our like lower bound. Okay, now let's move to implementation stage. We are actually going to implement only last 2 solution, because first 2 solution I think very generic, you can easily implement those. So let's go for the implementation. So the first implementation, which is hash map based solution. So let's write a method solution1. So I just write down the function definition. Right. Okay. So what we need to do, as I said, actually if we send this array to a hash map, then they will actually prepare, it will prepare pre-process the data so that he can answer in constant time, right? So in that case, actually there is a shortcut in Python. Suppose num frequency, like counter class, we can use counter class. So if we send counter class, it will actually return a number like this. Suppose for our case, if you look at the first example, then actually it will return something like that. So it will actually find out the frequency, but you can discuss it with your interviewer. Can you use this counter class or not? If you say okay, you can't use counter class, then you actually need to write 2 or 3 line of code to prepare a hash map like this. Okay, so now we have prepared our hash map. So what you need to do, what actually run a for loop for all the numbers in this array, right? So if num frequency num, if it is appear 1, then that's our answer, right? If not, then it will actually continue the loop. And if there is, if actually if it didn't find any answer, then what should it return? I hope you remember, we already discussed with your interviewer, if there is no answer, then we'll return -1, right? And we also discuss, if the array empty, then we'll also return -1, right? So this is our first implementation. So if we call solution 1, then let's submit it. So okay, there is one more thing. So in real interview, after writing your code, you definitely dry run your 1 or 2 test cases. Suppose if this is your test case, then you should definitely go through your code, because right now I am actually typing in code editor, but most of the time you need to write code in Google Docs or any other text editor. So it's better if you, after completing your solution, you should dry run 1 or 2 use cases. Suppose if we dry run these use cases, suppose what you have, so in that case it will actually have this, right? So it will come here, then it will take the first number is 2, so 2 is twice, so it will not return num, then go again, then it will come here, then again it will say check, okay, it is not 1, then it will go again, then it will come here, then 1 is 1 times, okay, it will return num. So this is actually working for this test cases. So if we submit it, then you see this accepted. Okay, now go for the second solution. The second solution, which is actually very very generic, which is actually bitwise based solution. So solution 2, I just write down quickly the function definition. Okay, so again, if not nums, so we just return -1, right? Okay, now what we need to do, we have to actually put is equal to 0, because first of all we have to actually XOR with the 0, right? So that's why actually I assigned 0 to output variable. Then we will run a for loop for whole array, then we'll keep the output, and output XOR num, and at the end we'll return 1. So that's our solution 2. So if you suppose if you try run again 2 XOR, so here you will 2 and it will get 2 again, so 2 2 0, then 1 1 0 XOR, then it's 1. So that's our answer, is 1. So if you change this, call this again, then submit, okay, so it is also accepted, right? So thank you again for watching this video. Please subscribe to my channel if you want more videos like this. Thank you.